All right, welcome back to Math 7. Today we're going to do lesson 98. And before we do that, I want to thank all my subscribers. I have 12. Before I had 9. So, this channel's growing. I'm going to go places, maybe, get my gold button before you know it. And today's lesson, what we're going to do is scale and scale factor, okay? So let's get into it. Because this is a little bit of a tough lesson. However, if you know how to do ratios and proportions, it's actually going to be quite easy. And that's one of the things that I keep repeating to you guys, right? I mean, for most of Math 7 and most of Math 8, when I actually do the answer keys, what I do is proportions. I literally have to do proportions in almost every single test I do. So if you know how to do it, you're going to be successful in this class and in Math 8. All right, in example 1, they are talking about scale. So the first thing I want you to understand is the scale is the same thing as a ratio. Okay, what is a ratio? If you guys remember, a ratio is a comparison between two things, right? So can I have improper ratios? Yes, because it's a comparison. For example, 3 girls to 2 boys, 3 to 2. Yes, it could actually be presented as a fraction, 3 to 2, or as a number with a colon in between, and then 2. And then there's another one in which is literally we write the word 2, T-O, and 2. So that is a ratio. 3 to 2, 3 to 2, 3 to 2. That's how you read that. So in the first example, we are talking about an airplane, a model airplane, which scale is 1 to 24. So what happens is that 1 inch of the model airplane is going to be 24 feet. 24 feet of the airplane, I think it is. I think it's in feet. Let me just check really quickly. Yes, it is actually in feet. So I was correct. So for every 1 inch is going to be 24 feet. Because obviously an airplane is quite big. So they say if in the scale plane, in the scale model, in the little model for the airplane, the measurement of the wing is 18 inches, how much does the wingspan of the actual airplane measure in feet? Okay, so what is the actual measure of the airplane in feet? And so of the wingspan of the airplane in feet. And so what we need to do is we literally take this as the scale. So you have to obviously make the little table. Please, I mean, one of the reasons we always tell you to do the table is because it's going to make it easier for you to do the proportion, which is going to be 1 over 24 equals 18 over x. And then you cross multiply, and then it's going to be 24 times 18 equals x. So all you have to do is multiply 24 times 18. 8 times 4 is 32, and a 3 goes up. 2 times 8 is 16, plus 3 is going to be 19, so a 0 goes here. 1 and 4 is 4, 1 and 2 is 2, so it's going to be 2, and this is going to be 13, and a 1 goes up, so 432. So in here, the actual wingspan of the airplane is going to be 432 feet, and that is how you solve example 1. Well, it turns out I was wrong about the feet, right? It was actually inches. So I did get the right answer in number, but the wrong unit, 432 inches. So because what happens is that they're saying for every 1 inch in the scale model, there's 2 feet or 24 inches in the actual measurement of the plane. And so if it's 18 inches, it would be 432 inches, the wingspan. But that does not tell me in feet how much it is. So you have to remember that 1 foot equals 12 inches. So now we have to divide 432 by 12. Okay, so 12 fits into 43 3 times because it's going to be 36. And 43 minus 36 is going to be 7. And then the 2 goes down, and in 72 it fits 6 times. because 12 times 6 is 72. And so it's going to be 36 feet. This is the actual answer. My bad about the last one. All right, for example 2, we're talking about Sophia. Maybe Sophia Palencia, I don't know. Perhaps she has a lot of free time now that we're not actually in the physical school building, and she decided to take up play modeling. Who knows? So what happens is that this Sophia, she actually wants to make a model of a car. And so the scale factor of the model of the car is 1 to 36. So for every 1 inch, there will be 36 inches in the car, right? I'm not going to make the same mistake I made in the last one. So I have to convert this unit right here into inches alone, because that is how much the car measures, all right? That's a certain part of the car measures that. What part of the car is it? The height. That's the height of the car. Okay, so the height of the car is 4 feet 6 inches. So what should be the height of the model? I know it's a very small car, but I don't know. Maybe it's a car for babies or something. So in here, what we're going to do is we're going to multiply 4 times 12, which is 48, right? And so it's going to be 48 inches plus 6 inches. And then 6 plus 48 is going to be 54 inches, right? So now we have 54 inches right here. Now, what is the height of the model? We don't know. We actually have to find out. And to find out, we're going to do proportion and cross multiplication. So 136 equals x over 54. And then we cross multiply. And it's going to be 54 equals 36 over x, and divide 36 to both sides, right? And we are going to see that both of these can be actually, well, first of all, we cross this out, and then we're going to see that these two can be actually be divided by 2. This is going to be 27, and this is going to be 18. Now this 27 and 18 can also be divided not by 3, because I know some of you are going to be like, oh, they can be divided by 3, but by 9. They can actually be divided by 9. So this is going to be 9, and this is going to be 2. Yes, I mean not 9 by 3, my bad, because I divided by 9, I get 3. 9 times 3 is 27, so I'm going to get 3 over 2, right? 3 halves is going to be what my model is going to be, the required height of the model, which is going to be 1.5 inches tall for the model. And that would be the answer to the second example. All right, the third example, we have 3/7 equals 15n. We should be doing cross multiplication, but for some reason the book is telling you don't do that. Why don't you just look at the scale factor? Sometimes it's actually going to be very helpful, and I actually have to admit that I do it from time to time if I see that it's very obvious. So what I mean by being very obvious is that I know that 3 times 5 is 15, and so instead of cross multiplying, what I'm going to do is I'm going to multiply 7 times 5, and I know that n is going to be 35. So how do we check? Very important to be able to check. So to be able to check, we're going to do cross multiplication, even though this right here just went all over the place. More like this. There we go. And so it's going to be 3 times n equals 7 times 15. So before we actually multiply 7 times 15, which we could do, and it would be something like 46 is 45, 45, 90. It's going to be 105, I think. But you don't have to do that because 105 is divisible by 3, so let's not worry about that. So what we're going to do is let's divide by 3 first, like I always told you that I prefer to do. So we divide by 3, so this becomes 1, and then we're going to divide the 15 and the 3. So by 3, we're going to divide both, and this is going to be a 1, and this is going to be a 5, and equals 7 times 5, which we thought that That's how we found out the first answer in the first place. And look at that. N equals 35. This is why math can actually be checked. All right, so in example 4, we actually are going to go a little bit back to yesterday's lesson, and we're going to talk about similar triangles. So we have similar triangles. I know they don't really look similar, but, you know, use your imagination, you know. Yeah, I mean, I tried my best. No, I really didn't try my best. I just, you know, this is what I drew before I actually started recording. But, you know, I think they look pretty good. So I don't think that I should redraw them. But I'm digressing. Okay, let's get back into topic. So similar triangles. So these two are similar triangles, right? Like we learned yesterday. And so what happens is that from here to here, there has to be a scale factor. So in this question, they're asking us, if you have two similar shapes, then could you tell us what the scale factor is? And this is actually really important because then we have to talk about corresponding parts. So corresponding sides, 16 it corresponds to 20, 12 corresponds to 15, and 20 corresponds to 25. And that is how we're going to do it. Usually what I like to do, and the way that usually you should probably do it, is put the smaller corresponding side divided by the biggest corresponding side, like this, 16 divided by 20. And so it will actually give you a fraction, but that's okay because we said that scales are actually ratios, and ratios are fine. So if we actually divide this by 4, we're going to get 4/5. Right? So that's my scale for my first side, right? For this part. So let's try it with 12 and 15. So 12 over 15. Well, what do you know? You can actually divide by 3. And so it'd be 4 over 5. Oh, okay. What about the last one then? Okay, let's try it with the last one. 20 over 25. What if we divide by 5? Well, it's going to be 4 over 5. Look at that. The scale factor will always be the same. And so the scale factor for this similar triangles is going to be 4/5. Okay, so for the fifth example and the last one, we have two three-dimensional shapes. They're actually rectangular prisms. And they ask us, okay, so could you find the scale factor in the area of one of the faces? Like how much greater is the area of one of the faces than in the other one? And then how much greater is the volume than the other one? So this is actually really interesting to see. And so what we're going to do is first of all, find the scale factor. Again, we have to find corresponding sides because if they're similar, they have a scale factor. And so we're going to put 3 over 9. 3 over 9 is going to be 1/3. Wait, let's check. 2 over 6. 2 over 6 is going to be 1/3. And 4 over 12, it's still going to be 1/3. So the scale factor is 1/3. Okay, that's great. Now, let's actually do the volume. So, the area. Sorry, the area. So the area of the face, the front face. Let's do this one. So the area is going to be base times height. And we have the base and the height here too. So 3 centimeters times 2 centimeters is going to be 6 centimeters squared, right? And in here, 9 times 6 is going to be 54 centimeters squared. So to find actually here the scale factor of the area, is that what they're trying to ask you? Yes. So they're trying to ask you how much bigger, how many times bigger is the area of this one than of this one. And to be able to understand how to do it, what I would actually ask you is find the scale factor of the area, because we found the scale factor of the sides, but not of the area. So let's actually find it for the area. So what we're going to do is we're going to have 6 centimeters squared over 54 centimeters squared. Now, the centimeters squared will cancel each other out because can we do math with units? Absolutely we can. I always tell you that you are able to do math with units because that's something that we always do in math. And then we're going to divide both of these, the 6 and the 54, by 6. 6 divided by 6 is 1, and 54 divided by 6 is 9, and so it'd be 1/9. Okay, so the scale factor is 1/9, meaning that the area is 9 times bigger. 9 times bigger. Let's just say 9 times, okay, bigger. I just forgot how to spell bigger. And then we have the volume here, and that's why I don't teach English. And then we have the volume here, right? And so we have to find the volume. So we already found the area of the base, 54 and 6, and now we just multiply it by 4, and that's how we get the whole volume. So 6 times 4 is going to be inside this little thing, is going to be 24 centimeters cubed, right? So cubic centimeters, centimeters cubed, the same thing. And then in here, we're going to have 54 times 12. I could do it this way. What is 5 times 12? 5 times 12 is 60, right? So 5 times 12 is 60. And then 10 times 12 is 120. But I could just multiply also 50 times 12. 50 times 12 is 600. Okay? 50 times 12 is 600. And 4 times 12 is 48. So this one right here is going to be 648 centimeters cubed. Right? So that's what you should know that it is, 648 centimeters cubed. And so they're asking you, how many times larger is the volume of the bigger one than of the smaller one? So you have to understand how to do this. So to do it, again, what we're going to do is put 24 over 648. Wait, what happened to the centimeters cubed? They're going to cancel each other out, just like in here. So we have 24 over 648. And these are obviously divisible by 12. Now, this is a lucky break for us because we already know that 648 divided by 12 is 54. And 24 divided by 12 is 2. And these can be divided by 2 again, and it's going to be 1 over 27. So it will be 27 times larger. Now wait, before we actually finish here, I want you to understand something. When it is actually just the lines or the sides, it will be 1 to 3, okay? But when it's the area, it will be 1 to 3 squared, or 1 over 3 squared. What does that mean? It means that it will be 1 over 9, because 1 squared is 1 and 3 squared is 9. Look at that. It's the same thing as in here. What about the volume? Well, the volume is not squared, but it's going to be cubed. Look at here, it's cubed. So what we're going to do is we're going to get 1/3 and we're going to cube it. And it will be 1 over 27. Well, that's crazy because that's what we got here. And that's how you actually find the scale factor for the perimeter and the sides. So the scale factor is going to be 1/3. Then when we talk about area, you have to square it because area is squared. And then when we're talking about volume, you have to cube it because volume is cubed. And that is it for lesson 98.